In this animation, we will continue exploring the model of photoelectric emission and the way it matches the observed current-voltage relationship. So we switch on the lamp, then check the positive and graph boxes, then we'll move the applied voltage slider to the right and back to its central zero position to produce a current voltage curve for positive voltage. Next, we check the negative box and we will move the slider just to the left of the 0-volt position, then observe the current voltage graph and the electrons. So what can you notice observing these two? The electrons are now experiencing a downward force, where fewer of them reach the upper negative plate, thus the current falls. Some electrons, however, began their journey with enough kinetic energy to reach the upper plate. The fastest ones have maximum kinetic energy, Ek max. Now if you continue to move the slider slowly further to the left, then the current falls to zero when we reach the stopping voltage Vs. The magnitude of the stopping voltage depends on the maximum kinetic energy of emitted electrons and is related to it by the following equation, where Ek max equals to small letter e multiplied by Vs, where Ek max is the maximum kinetic energy, Vs is the stopping potential, and the small letter e is the charge of one electron, which is equal to 1.6 multiplied by 10 to the power negative 19 coulombs. Note that although the stopping potential appears on the graph as a negative voltage, it is normally quoted with a positive value.